Hey, Probstats kids, this is Dr. Callahan with week 13, Monday. How are you guys doing? Go ahead and pause the video and answer the following 3 questions on your warm-up log. All right, so when I saw you guys on Friday, you guys had a project that was due. So this is a rubric for the project, and just to go over the specifics of it, there are 3 parts of the project. You need to include the following vocabulary words for part A. Part B lists the 3 parts of the Euler theorem. You can go ahead and take a look at my definition of it right here, and then perhaps rewrite it to make it your own. And then part C, which is the part that is majority of the poster itself, is to create the diagram that represents the Euler's path, circuit, neither. And if you need an example, these are mine right over here: circuit, path, and neither. And make sure you, on the top of the paper, you have Euler's path and circuit project by with your name. So in class today, we are going to be looking at other people's project, and you are going to have an opportunity of assigning them points. So there are 1, 2, 3, 4, 5 different categories, and the most you can have is out of 4 points. So your total is out of 20. So what I would like you guys to do is go around, look at these 4 different posters, assign them a grade, and then tape the rubric onto each of those posters outside. So if you're doing this at home, just keep in mind when I see you guys next time, this is what we're going to be doing. So make sure you have your posters ready to go. All right, so what I would like you guys to do is we are going to talk about Euler circuits and path. I have 15 questions on the Desmos that you're going to be using. So looking at this part here, I'm just going to go ahead and sign it to your class. See if I can go ahead and so then what I would like you guys to do is you're just going to go to student.desmos.com and then type in the code 7C2EUD. Once you guys get in there, you are going to be able to see the following questions over here. This is the first slide. Once you're done reading it, go on to the next one. Here, you're going to ask, is it a circuit, path, or neither? Answer it, go to the next one, and then so on and so forth. So this is your assignment for today, or part of it at least. Then it transitions to a Fleury's algorithm tutorial, which is going to start up after this. So it gives you a brief little introduction to it. You can kind of play around with it and do that. And then it continues on until slide 15. So make sure you do that. All right. Next, what I would like you guys to focus on is your guided notes for today. But before you do that, I do have a video I would like you guys to watch. So this is what the video looks like. You're going to go ahead and type this tiny URL in, or what you can do is you can take your phone and take a picture of this QR code, which should take you directly to this video. It's about 24 minutes. Just watch the first 10 minutes of it, and it actually goes into a little bit more complicated information in terms of Euler's graph and path and circuits. And it's kind of like the beginning of computer science in a way, because it talks about the start nodes and the edges and vertices. All right, next what I'll have you guys do is take a look at your guided notes for today, and it looks like this right here. And with that said, let's go ahead and get started. All right, in each graph below, tell me if it's an Euler's path, circuit, or neither. Well, with this one, it is a circuit. And the reason for that being a circuit is that you start off on this point here, and you go this way, this way, this way, this way, this way. The start and end point are exactly the same. This one here, it is a path, mainly because we start here, this way, this way, this way, this way, this way. The end and starting point are done 2 different points, but there are no retracing or repeating of the edges. This one here is also a path. If I start right here, this way, start, end. This one is also a path. If I start right here, you end differently than when you started. This one's going to be neither, and you can go ahead and try with this one on several different occasions. So if I were to do this side, oh, and here I stop right there, so it didn't work out. Let's try it again, maybe on this point. And I said to stop. So in this situation, it's neither, because you're not going to be able to finish the path without retracing the edges. For the following one, for 4, go ahead and pause the video and answer this one on your own. Here are my answers right here. I thought the one that was really interesting is this one right here, which took me a little bit while to kind of figure out how to go about do this, but let's take a look. Actually, I should start here, there we go. And then go all the way through, up, over, and down. There we go. So you started right here on this point, and you ended on that point. All right, this one is also an Euler circuit, or it is an Euler circuit. So you go up, actually, hold on a second, maybe not. Let's try this one more time. That didn't work out the way I expected it. Start right here. Let's try one more time. Actually, I don't see what the circuit is. Maybe you guys would do a better job than I would. Maybe from the inside. Oh, there we go. That's actually how you started. Right there. All right. Here, number 5, find the Euler circuit for graph. Show your answer by labeling edges 1, 2, 3, and then so on in which they are traveled. So how many edges are there? You should have 24 edges. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then so on and so forth. This one, you should have 29 edges. And let's go ahead and take a look at these right here. I'm just gonna go ahead and give you guys the answers. You can just go ahead and copy it down. All right, you guys, that's basically it to the end of this. So I will highly suggest that you guys go ahead and watch the video, make sure you complete the Desmos activity. And as always, stay safe and healthy. I'll see you guys next time. Take care.